So I'm invested in the share scheme and we've got value against time. And then we're given some information. Exactly 6 months after the investment, the value of the shares was 2375. So that's my V and that's my T. And this is in months. After 1 year, which is 12 months, it's important to be consistent in our unit and its T is in months. The value of the share was 2825. So that's V here and that's T here. Using a straight line model, determine an equation for V in terms of T. So I'm going to show you two ways to do this. Both are going to use essentially the equation for a general straight line, y equals mx plus c. But in our case, in method one at least, it's going to be v instead of y, and it's going to be m times t plus c. You don't have to call them m and c, you could call them something else, but this at least links in with the intercept and the gradient. And then I can substitute my values in. I'm gonna get two pairs of equations. So 2375 equals 6m plus c. I've replaced t by 6. And then 2825 equals 12m plus c. Actually, I've got simultaneous equations that I can solve. So actually, I'm going to write them in the opposite order and then subtract them to eliminate c. That gives 450 equals 6m, because the c's cancel. And that therefore gives m is equal to 75. Now I can substitute back in to work out c. I can put it back into either one. So 2375 is equal to 6 times 75. (450) plus c, and this gives c is equal to 1925. Now for finally, remember we're asked to determine an equation for v in terms of t. Therefore v is equal to 75t plus 1925. Good. It's a nice approach, and actually this approach kind of lends itself to other situations where you might be trying to fit a model to some data points. You know, maybe it's a logarithmic graph or something. So it's worth like learning about that. I do want to show you another way you could do it, because it's actually essentially a GCSE topic. You could imagine that you've got 2 points on a graph, 6, 2, 3, 7, 5, and 12, 2, 8, 2, 5. And you get asked at GCSE and in A-level actually to find the equation of the line through these 2 points. And typically, you first of all find the gradient, and that's using y2 minus y1 over x2 minus x1. You can also just draw a picture and see that you're going along 6 and up 450. In fact, that's what we end up getting here. And then we divide them. Okay, I've just done this minus this divided by this minus this. And that again gives us our 75. And now you can either use y equals mx plus c, but it'd be y equals 70, sorry, it'd be v equals 75t plus c. Or actually, we could use our y minus y1 equation, but it's actually going to be v minus v1 is equal to m t minus t1. It's the same sort of thing. I've just replaced x and y. This is always the best equation to use for these straight line graphs because it just avoids you having to rearrange. So v minus 2375 is equal to 75t minus 6. And if you rearrange that, you'll get exactly the same thing. So just a different approach. I just wanted to kind of remind you that actually this is not a completely different question to what you would have been asked previously. In part B, we're asked to explain, so Sam's original investment in the scheme was 1,900. Explain whether or not this fact supports the use of the straight line model in part A. So we need to compare the two. So in the model, V is equal to £1,925 when t equals 0. It's just our intercept. So this is at the start. And the actual value was 1,900. So that's pretty good. I mean, it's not far off, is it, when you think about it? A model is never going to be exactly perfect. It's not going to be a perfect straight line, but I said this is close. This is close to the actual value of 1,900. So I kind of said it the wrong way around, haven't I? But so the 1,900 fact supports the straight line model. If it actually been 1,000 or something like that, then you'd be like, oh, actually, this doesn't look right, but it's pretty good.